Hey, what's up guys? Ave here doing a video tutorial on Tech 3 production. Now, the reason why I'm doing this video is because, whenever I wanted to know more about this process, I was very surprised on how little information was out there on the internet. Well, just like everything else in this game, I more or less had to find out by trial and error. But I felt compelled to go ahead and give this a shot, and hopefully motivate some of you to try it out for yourself. Okay, assuming you're going to have a pause anchored in wormhole space, this is where you're going to find 90% of the materials for T3. The other 10% needs to be purchased off the market. Also, you're going to need a few structures anchored in your pause for the construction of these subsystems. So before we begin, let me just quickly talk about what you're going to need overall. For structures, you need one component assembly array, one experimental laboratory, one polymer reaction array, one hybrid polymer silo, two biochemical silos, one normal silo, and a subsystem assembly array. So for the items bought off the market, these include sleeper component blueprints, which I'll go over a little bit later, certain science data cores, which I'll also explain a little bit later, and reaction schematics. Now for the labor, you need sleeper salvage. You also need components from hacking or analyzing radar and magnetometric sites, gas from ladder sites, and minerals from gravimetric sites. Alright, so our first question is, where do we start? Well, you first need to figure out which subsystem you're going to make before you start setting off reactions like a mad scientist. As you can see, I have a malfunctioning power core that I found from a magnetometric site representing the potential engineering subsystem blueprint copy I'm hopefully going to get from. Looking at the required materials to conduct the reverse engineering of this, it says we need 3 engineering subsystem engineering data cores, which are found from radar sites, 3 quantum physics data cores, which are found from the market, and 1 RAM hybrid technology, which is also from the radar sites. In addition to these materials, there is one very important component that is missing: the race-specific hybrid tech decryptor, which is found from radar sites. This will determine the race of the subsystem will be used for. Before we initiate this job, let me just tell you that the adjective describing the relic, in this case malfunctioning, determines how many runs you're going to get for a successful reverse engineering job. Wrecked means you're going to get a 3 run, malfunctioning means a 10 run, and intact means a 20 run blueprint copy. Okay, so now that that's out of the way, let's fire up the lab and get this job started. The good news is it only takes an hour to complete a job. So the job was successful, and now we have a 10-run blueprint copy of our Mimitar engineering subsystem. Now that we have our blueprint, we know exactly which materials are required to build it. Here's what we need: 1 optimized nano engines, 1 fullerene intercalated sheets, 1 fullerene power conduits, 1 metallofullerene plating, and 1 nanowire composites. Okay, remember the sleeper component blueprints that I talked about that you get from the market? Let's break this down one by one. We know we need 1 optimized nano engine, so let's check what the materials needed to make one of these by looking at our sleeper component blueprint of it. Okay, so we have a number of materials here, but the ones I want to focus on are the polymers. The other ones are obtained from the sleeper salvage, which you will have no problems getting enough of. So it looks like we need 5 graphene nanoribbons, 10 lanthanum metallofullerene, and 10 PPD fullerene fibers. Right, so this is where our silos come into play. Let's pull up the reaction schematic for graphene nanoribbons. As you can see, we need 100 fullerite C28, 100 fullerite C32, and 400 noxium in order to create 30 graphene nanoribbons. Obviously the 30 is greater than the 5 that we need. there's nothing you can do about it, you're just going to have some left over for the next job. Okay, so our science lab structures must first be offline in order to perform any sort of transfer, be it placing or removing material. So first, let's open up the production layout by right-clicking our tower and selecting Manage. From there, click on the Processes tab, and then selecting the Production sub-tab. Here we see our layout of our science lab. But before we start messing with anything, we need to locate our graphene nanoribbon reaction schematic and place that in our polymer reaction array. This tells the reactor what you intend to create. From here, show info on the schematic to see what materials you're going to need for this reaction. In this case, we need our two gases, C28 and C32, and of course our noxium. If you wanted to mass produce these reactions, simply multiply each material by the amount of cycle jobs you intend to do. For example, if you wanted to double your output of graphene nanoribbons, all you have to do is double the amount of minerals and gas. This process should take about 2 hours. Also, note that you can only have one type of reaction at a time, because you simply cannot fit additional reaction schematics into your polymer reaction array. So let's get started. First, we need to set each silo to the appropriate mineral or gas type, including the product we will be making. So click on the Change Type next to the first biochemical silo and find our first needed gas, C28. Now let's do the same for the second one. We're going to need C32 for this one. For the normal silo, we need to select our correct mineral, in this case noxium. And finally, let's set our end product to what we want to be, graphene nanoribbons. With these structures remaining offline, let's move the required minerals and gases into the structure. Gases go into the biochemical silos, and it does matter which one, but there's really only one way to find out, so if it doesn't go in the first one, then put it in the second one. Next, let's put our noxium into the normal silo. From here, you need to online each of these structures. Okay, now we need to play connect the dots by clicking and dragging the noxium icon from the right part of the layout to the left icon on the left part of the layout. Same with each of the gases. Finally, you have to drag the graphene nanoribbons icon from the top right of the layout down to the bottom left icon. Now it should say starting up. Now don't forget this last step. Make sure you click Apply. Alright, so our reaction is done. Now to obtain our graphene nanoribbons. We first need to open up the layout and offline all of these structures. Now we can pull out our 30 graphene nanoribbons. And don't forget your reaction schematic. Congratulations, we've just made our first polymer. But don't get too excited, there's still a lot more on the plate. I won't be going over each of these reactions for the sake of time, obviously, but now you know how to make polymers. Once you have enough of each polymer and the salvaged components from the sleepers, it's time to manufacture our sleeper components. First, you need to online your component array and manufacture from the blueprint just like any other manufacturing job. Okay, so we have all 5 sleeper components needed to make a single subsystem run. Our long and hard work is about to pay off. This is the best part. Start the manufacturing job and sit tight. Finally, it's done. We have just created our very first subsystem. Now get that thing in a high sec and slap it on the market. Or you can use it, of course. Well, I hope you guys got something out of this video. I hope it motivates you to do your own Tech 3 production in the near future. Well, thanks for watching. Fly safe.